In this video, we're going to preview the next unit. If we take a look at number 1 and we figure out, okay, what value of x would make that true? 10 to what power? 10 to what power here will equal 100,000? Well, we know that in this problem, x will equal 5. Right? 10 to the 5th power, or to the exponent 5, is equal to 100,000. In this next problem, we have to figure out, okay, what value of x here will make it equal to 1,000? Well, 10 to the exponent 3 will equal 1,000. If you don't have a graphing calculator, you can Google the word GeoGebra. GeoGebra. After you Google GeoGebra, on the top of the page, you'll see a spot where you can click on Graphing Calculator. If you click on Graphing Calculator, it will pull up a graph, and then the calculator function you can do on the left-hand side. If we go ahead and continue, 10 to what exponent is equal to 1? 10 to the exponent of 0 will be equal to 1. Go ahead and pause this video and see if you can find out letters D and E. For letter D, you should have got x equals -2. And for letter E, you should have got x equals -3. Right? You're just guessing and checking. 10 to the exponent -2 is 1 over 100, and 10 to the exponent -3 is 1 over 10,000. See if you guys can find letters F and G. You can go ahead and pause the video, and when you're finished, you can unpause the video. For letter F, you should have got x is about, I'm going to put a little squiggly line here for about, or approximately 2.58 if I rounded to the nearest hundredths place. And for letter G, you should have got x is approximately -0.70. A way that you could have done that is, if you know that 10 squared is equal to 100, and you know that 10 cubed is equal to 1,000, and you know that 378 is between 100 and 1,000, so you know that this x value has to be between 2 and 3, and 2.58 would check in that case. For letter G, you know that 10 to the -1 is equal to 1 over 10, and you know that 10 to the 0 is equal to 1, and you know that this x here has to be between 0 and -1, because 1/5 is between 1 and 1/10. So -0.70 is a reasonable answer for x. Go ahead and try numbers 2, 3, and 4 for your assignment. Let's look at these three equations. These three equations represent a fictional notation. Remember, fictional just means fake, right? So this is just a made-up notation to help you understand the notation, the logarithmic notation, which is real notation, here to come. See if you guys can find the relationship between this 2, this 8, this 3, this 5, this 25, this 2, and this 3, this 81, and this 4. Go ahead and pause the video and see if you can find the relationship between the three red numbers, the three blue numbers, and the three green numbers. If you notice, the 2 is the base, the 3 is the exponent. If, for this equation, 2 to the exponent 3 is equal to 8. Right? 2 times 2 times 2 is 8. Right here, 5 squared is 25. And in green, we have 3 to the exponent 4 is equal to 81. Right? 3 times 3 times 3 times 3 is 81. Go ahead and pause the video and see if you can fill in these next 4 blanks. So if 2 is the base, 2 to what exponent would be equal to 16? That would be 4. So we're going to put 4 here. If 9 was the base, 9 to what exponent would be equal to 81? That would be 2. So 2 would be this blank here. If 5 was the base, 5 to what exponent would be equal to 125? 5 to the exponent 3. And then last, if we did, we'll do it in blue again. 11 to what exponent will be equal to 11? That would be 1. So this notation here is fictional. This notation here in red is the real way to write a real way to have logarithmic notation. We just used L for logarithm in our fictional notation, but it's going to be the same thing. So this 8 is our base. So 8 to what exponent is 64? 8 to the exponent, 8 to what exponent is 64? So this would be 2. 42 here is our base, so 42 is our base also here. To what exponent is equal to 42? So that's going to be equal to 1. Here, our base is 10. When we write it in this other form, this exponential form, 10 is our base. 10 to what exponent is 1,000? That's going to be equal to 3. And then lastly, 4 to what exponent? 16 to what exponent is equal to 4? It's going to be 1/2. So we can create a rule now. This symbol right here means if and only if. Sometimes it's abbreviated as IFF. So log base A of C equals B if and only if A, the base here, equals the base here, to the exponent b equals c, which is this c.